Hello students, good morning. So welcome to the session 14 on work energy power topic. In Canada, we will try to get into the specifics of the types of collision. And already previous session we have talked about what is the basic understanding of the collision. We also talked about what are the classifications of the collision. Okay, wow. So from this session, right, we'll try to get into each of these categories of collision. Classify panna ஒரு category அதோட detailed நம்ம cover பண்ண போறோம். ஓகேவா? So பாருங்க, this is what we have seen, right? So we classified the collisions into this matrix. What is it? We can have a head-on type of collision. Head-on is also called as what? 1D collision in சொல்லலாம். Oblique. Okay. So sometimes head-on is also called as a direct collision and solluvaanga. Oblique is also called as what? Indirect. Okay. Head-on can be also called as what? 1D and solala, or you can also call it as direct collision. Oblique collision can be also given the name indirect collision. Okay. So paranga, we can have perfectly elastic. The kinetic energy of the particles initially is equal to kinetic energy of the particles finally. Okay. So inelastic and sonna kinetic energy, initial kinetic energy value will not be equal to final. Maximum case loss kinetic energy loss agum. Okay. So we have perfectly inelastic. Idoda significance and loss is going to be maximum. The loss of that kinetic energy is going to be what? Maximum. And our particular scenario we call it as perfectly inelastic collision. Okay, va? So we will start with the perfectly elastic collision in a head-on type. And in case of head-on or a 1D perfectly elastic collision. So the kinetic energy of the particles before the collision will be equal to kinetic energy of the particles after the collision. Okay, va? So the total kinetic energy is going to be what? Conserved. Before the collision, whatever the kinetic energy there is there, collision kapro nama and the particles or kinetic energy add panna, it will be the same value. Okay, so this is what is the characteristic feature of the perfectly elastic collision. Okay, va? So when we look at the collision process, and obviously in the last class so on the collision during the collision there is going to be some kind of a compression or deformation and solala. The objects are going to be what? Getting compressed or deformed. Okay, so during the collision time some of the kinetic energy will be converted into this potential energy, like the elastic potential energy and solala, because it is getting compressed, right? So that is what? Elastic potential energy. So this is a very important theoretical question also, in one of the previous year NEET la kadiyadu, but in some other competitive examination, right, adha in the question vandhathu enna theriyuma, perfectly elastic collision and sonna, what are we saying? Kinetic energy of the particles before the collision is equal to kinetic energy of the particles after the collision. But is kinetic energy of the particles going to be conserved during the collision time? During the collision time and the compression or the deformation adu nadakkumbodhu, is the kinetic energy going to be conserved? Agumagada. So when the things are getting once the collision has begun, the objects will be getting compressed against each other. Like you have the object 1, the object 1 the object 2. So once they come into physical contact, there is going to be some kind of a deformation. During the collision there is going to be some kind of a deformation. So what is going to happen? Deform agarthukku you have to spend the energy, right? That energy is what you call as the deformation energy and solala, or the elastic energy and solala. Okay, va? So some amount of kinetic energy is going to be converted into this the elastic potential energy or the deformation energy. Okay, but since it is a perfectly elastic collision, and the collision time முடிஞ்சதுக்கு அப்புறம் as the objects are receding, right, so maximum compression stage reach ஆகும். நம்ம அந்த spring case ல பேசுன மாதிரி what is going to happen? the objects are going to get compressed and you will reach a maximum compression stage. Adukaprom they will start moving away. Okay va? So when you reach this maximum compression state, appa enna theriyuma, you would be having maximum amount of the kinetic energy converted into potential energy. Angalende the object will start receding away. So when they are receding, the object will start gaining their shape back. When you say perfectly elastic collision and sonna, the initial whatever the kinetic energy will be equal to what? Final kinetic energy of the particles. One particle at the, if you are trying to look at each and every particle, kinetic energy initially may or may not be same final kinetic energy value. But in the total value of all the particles or kinetic energy initial state is equal to what? Total value of all the particles or kinetic energy in the final state. Okay va? So during the collision time, some of the kinetic energy will be changed into what? The elastic energy, or we can say the deformation energy. Okay va? So note panikonga, during the collision time, right? When normal enna solluvom, perfectly elastic collision nu sonna, okay, we will always remember this: kinetic energy initial is equal to kinetic energy final. But ippude or question vandha nichukonga, what is it? During the collision time, what happens? During the collision time, what happens? The kinetic energy, some of this will be changing into what? The elastic potential energy or the deformation energy. Okay va? But since it is a perfect elastic, as the collision is finishing, the objects will regain their shape and structure. Perfectly or elastic spring madri, they will regain their shape and structure. So adanala the final kinetic energy of all the particles will be same as initial kinetic energy. Okay va? But during the collision, some of the kinetic energy will be changed into the elastic potential energy or the deformation energy. Idu eppadi theriyuma, we can just visualize this with a spring connected system. Paranga. So the object M1 vechukonga, which is moving with the velocity u1. Inga enna irukka object M2 which is moving with the velocity u2. Both are in the same direction. So this is the requirement for our 1D, one dimension. So எப்போ collision ஆகும்? When u1 is more than u2. See, m2 is going in the same direction, m1 is also going, but m1 is coming with a higher speed. So அதனால என்ன ஆகும்? After some time they both will come into physical contact. That is where, so பாருங்க, in the case B பாருங்க, this is where actually the collision is starting. Okay, collision start ஆன உடனே we will get what? The impulsive forces. Paranga. So collision start now, they will get what? Impulsive forces. Impulsive forces are what? Internal forces. Paranga. If M1 is applying a force F, M2 will also apply the same amount of force but in opposite direction. Action reaction pair. Okay va? So paranga, it is like what? M1 is coming, it is going to compress the spring. So it is going to keep on compressing the spring. This is maximum compression state. The maximum compression state is அதுக்கப்புறம் நம்ம கம்ப்ரஸ் பண்ண முடியலன்னா what should be happening? Whatever the velocity of this m2, velocity change ஆயிட்டே இருக்கும். Whatever the velocity of the m2 will be equal to the velocity of the m1. பாருங்க, so if you have a spring, m2 oda velocity is equal to m1 velocity, means what? Both are moving with the same velocity. அப்ப என்ன? The spring will no longer be able to get compressed any further. Initially, why is it getting compressed? பாருங்க, m1 oda velocity is higher, so it's keep on coming. So adanal spring is getting compressed. You are reaching a stage where m2 oda velocity rate is equal to m1 velocity. Apna the spring will not be able to get compressed any further. Adukapra enna theriyuma, because there is a force, right? Paranga, the force on m2 is forward, so adanal m2 oda velocity will keep increasing. What about the force on m1? Reverse. So m1 oda velocity will keep on decreasing. Appadana. So during the collision time enna nadukum paranga, m2 oda velocity will increase, m1 velocity will keep decreasing. Okay, so the collision finish agumbodhu, what is the collision finishing stage? Means spring would come to the natural state. When the spring is coming to natural state, right, appadana paranga, m2 would have gained a higher velocity, so that's why, right, so it is able to go faster than the m1. So m2 oda velocity v2 will be what? Higher. V2 oda value will be higher than v1. So this is how we can see. Instead of looking at it like two objects getting deformed, idu eppadi nama paakala? you can see it like two objects having a spring in between them. So that is what is the nature of the perfectly elastic collision. So whatever the initial kinetic energy of the particles. So now what is it? Half m1 u1 square plus half m2 u2 square. That is the initial kinetic energy of the particles. What about the final kinetic energy of the particles? Half m1 v1 square plus half m2 v2 square. So initial kinetic energy of all the particles is equal to final kinetic energy. But paranga, during the collision time, the spring is getting compressed. So spring is going to have what? Like the way we said, right? Deformation. We are trying to visualize this with a spring. Okay. Spring is going to have what? Potential energy. Because when the spring is compressed means potential energy. So during the collision time, some of the kinetic energy of the particles is getting converted into the potential energy. So we visualize by using a spring. But actually, two objects are the spring. What will be there? The objects at the molecular level, each molecule can be seen like a spring. The molecules are going to get compressed. They will come back to the original shape. Like the spring is getting compressed. The spring is able to regain the original shape. Okay. So during this process, what is happening? The velocities of the particles, m1 velocity change, m2 velocity is also changing, but the total kinetic energy initial will be equal to total kinetic energy final. So what is happening? The spring is able to come back to the original shape. But in inelastic collision, the spring will store some deformation. Inelastic and so what is it? The spring is going to have some deformation. So some amount of energy is going to be stored inside the spring as a deformation or something. So the kinetic energy of the particles will not be conserved. That is the situation in case of the inelastic collision. Okay, so this is how we can visualize how a head-on elastic collision will happen with the help of the spring system. Okay, but normally between two objects, you will not have a spring, but there you can see the molecules like a spring. So when two objects are getting collided means, and the surface molecules, they are like, they are going to get compressed like the springs. They will again expand back. Okay, so this is about the perfectly elastic head-on collision. In we are seeing, okay, the object m1 is having a velocity u1 and object m2 is having a velocity u2. We are saying final velocities are v1 and v2. One question that we'll have is, can we find out the v1 v2 values? Find out panna mudiyuma? Because this is an important question for the NEET examination. I think at least 4 or 5 times as it is based on the formulas for the v1 and v2 in a head-on elastic collision. If you know the masses of the objects, kandipa they will give us. Say for example, they are giving us the mass of the two objects m1 and m2. They are having the initial velocities u1 and u2. Okay, same direction. Okay, same direction. So now we will take it as it is. Okay, but remember, if you talk about the 1D collision, you can also have the velocities in exactly opposite direction. And now along a straight line you can have two possible directions. Along a straight line you can have two possible directions. If u1 and u2 are in opposite direction, then we will use the sign convention. Sign convention means for one direction positive and opposite they will take it as a negative. Like the way we do in kinematics, right? Kinematics, if you take the quantities upward as positive, like in vertical straight line motion, they will take upward as positive means downward will be negative. And horizontal straight line motion, if you take right side to be positive, left side will be what? Negative. Okay, so in case of the 1D motion, the velocities will be along the straight line, means they can have two possible directions. Okay, so they are having velocities u1 and u2 which are in the same direction. What you will do, you will have to take the values along with the sign convention. Okay, they collide such that after the collision their final velocities are v1 and v2. Then this is what? This is the perfectly elastic head-on collision. So idhula nama irukku, we are in the perfectly elastic head on collision. So paranga, any collision, right, because it is the internal phenomena sonna, remember the discussion we had in the previous session, we can neglect the effect of the external forces during the collision. Apdi nama neglect panna, what is going to happen? The total momentum of the particles before the collision is equal to total momentum of the particles after the collision. Idhula enna, like, this conservation of momentum solluvom, the conservation of momentum principle, right, இது வெறும் இந்த elastic collision மட்டும் கிடையாது, this will be applicable for all the type of collisions, any collision. Okay, so பாருங்க, first thing is what, we can apply the conservation of momentum. அது நம்ம அப்ளை பண்ணலாம். அப்ளை பண்ண என்ன வரும்? initial momentum என்ன? For the particle m1 it is m1 u1, for the particle m2 it is m2 u2. Final momentum is what? m1 v1 plus m2 v2. இங்க என்ன தெரியுமா? Let us bring all the m1 on one side. The m1 term மட்டும் நம்ம ஒரு சைடு எடுத்துட்டு போலாம். What is it? m1 u1 minus m1 v1 வருது, is equal to m2 v2 minus m2 u2. இங்க பாருங்க, m1 நம்ம அப்படியே காமன் எடுத்தா u1 minus v1 is equal to what? m2 into v2 minus u2. ஓகேவா? So then we will keep it as equation 1 ன்னு வெச்சுக்கலாமா? This is what, this is our equation 1. So how are we getting it? எப்படி வருது? By using the conservation of momentum. இப்ப என்ன தெரியுமா? We are going to derive that. We are going to derive the formulas for v1 and v2. v1 v2 ஓட formulas நம்ம derive பண்ண போறோம். Okay, அடுத்தது என்ன? What is the next thing? So we will write it at the top. So பாருங்க, what is the first equation? m1 into u1 minus v1 is equal to what? m2 into v2 minus u2. Okay va? So this is coming from the conservation of momentum equation. After that, now we look at the conservation of energy. Why? Because we are in the elastic collision. So we are in the elastic collision, which means what? We can apply the conservation of energy. And our conservation of energy means we are talking about the conservation of kinetic energy of the particles. Okay, so we can apply conservation of kinetic energy because it is what? Elastic collision. So total initial kinetic energy of the particles, half m1 u1 square plus half m2 u2 square is equal to what? Total final kinetic energy of the particles, half m1 v1 square plus half m2 v2 square. Idhula theriyuma, let us cancel the half on both sides. Rendu pakkam apdiye we can just cancel the half. Okay, cancel panna enna varum? m1 u1 square plus m2 u2 square is equal to what? m1 v1 square plus m2 v2 square. Idhula enna theriyuma, thirupi appadida, take all the m1 onto one side, take all the m2 onto the other side. So m1 into left hand side enna varum parunga, u1 square minus v1 square is equal to RHS la m2 into v2 square minus u2 square. So neenga parallel work out panni paakalam, so that you will be able to get the expressions. So already nama kitta oru equation iruka. Engala indha varudhu? The first equation, conservation of momentum principle. Ipo enadhu? We are having the second equation. This is coming from the conservation of the kinetic energy. And we are dealing with what? We are dealing with the head-on elastic collision, right? So adanala kinetic energy of the particles initially before the collision is equal to kinetic energy of the particles after the collision. Ipo enna theriyuma? Parunga, what is the next step? The rendu equations la we have to eliminate the things. See, idhula parunga, m1 namakku theriyum, m2 theriyum. And madri u1 is also given, u2 also will be given. So what are the unknowns here? Unknowns enna parunga, v1 namakku theriyadu, v2 namakku theriyadu. So we are having two equations or two unknowns. Solve panna mudiyuma? Solve panna mudiyum. Enna? Because if we are having two unknowns, we require minimum two equations. Appadidana? We are having two unknowns, we require minimum two equations. So parunga, eppadi inda v1 and v2 solve pandrathu? So let us divide equation 2 with equation 1. Why are we doing it? Yoshi parunga. See, m1 and m2 values are there. In the left hand side la m1 irukka, the madri inga m1, inga enadhi m2 is there, m2 is also there. So if we divide means enna agum parunga, divide 2 with 1. So 2 means m1 into u1 square minus v1 square divided by m1 into u1 minus v1. அப்படியே m1 cancel. RHS ல என்ன இருக்கும்? m2 into v2 square minus u2 square by m2 into v2 minus u2. ஓகேவா? ஸோ இங்கே அப்படிதான் m2 cancel ஆயிடும். cancel பண்ணா what is the thing that is the LHS ல numerator பாருங்க. what is the numerator part LHS ல u1 square minus v1 square. இது எப்படி இருக்கா? a square minus b square மாதிரி தானா? what is a square minus b square means u1 minus v1 into u1 plus v1. denominator ல u1 minus v1 அது அப்படியே cancel ஆயிடும். is equal to RHS ல பாருங்க. அதே அப்படி தானா? v2 square minus u2 square means what? v2 minus u2 v2 plus u2 divided by v2 minus u2. இங்க பாருங்க v2 minus u2 cancel ஆயிடும். so what are we having finally? u1 plus v1 is equal to what? v2 plus u2. just இங்க rearrange பண்ணி பாருங்க. rearrange அண்ணா take the v1 to the right side, bring the u2 to the left side. அப்படி நம்ம rearrange பண்ணா what you will have? u1 minus u2 is equal to v2 minus v1 ஆயிடும். u1 minus u2 is equal to what? v2 minus v1. okay, so இங்கில என்ன தெரியுமா? let us just look at it. அப்படியே நீங்க அந்த u1 minus u2 நீங்க right side எடுத்துட்டு போனா it will go to the denominator. it will go to the denominator. so 1 is equal to v2 minus v1 by u1 minus u2. இங்க பார்த்த மாதிரி இருக்கா this expression, right? what is it? v2 minus v1 by u1 minus u2. what is it? what is this expression? it is the coefficient of restitution dana. what is this? v2 minus v1 by u1 minus u2 means what? then the coefficient of restitution dana. so in a one dimensional or head on perfectly elastic collision, what will be the value of coefficient of restitution e? E oda value anna 1. so this is another standard result. okay, so e enna solittu we have defined in the previous session. so when we go to each and every type of collision, right, adula enna we will try to look at what will be the value of e. so நம்ம already idla sollirukom enna e oda significance will be mostly for the one dimension collision. so e represents what? the impact of the collision. what is the e concept? the relative velocity of separation after the collision, which is the v2 minus v1 divided by the relative velocity of the approach before the collision, adana the u1 minus u2. okay va? so we are able to get one other result for the head on elastic collision. what is it? for the head on elastic collision, coefficient of restitution oda value annade it is 1. for the head on elastic collision, coefficient of restitution e oda value annade it is 1. okay va? so ipo parunga, before we got that e expression, right, idha namakku irukka. what is it that we are having? u1 minus u2 is equal to what? v2 minus v1. enga theriyuma? just take the v1 to the left side. okay, so the e oda derivation mudinjது. so for the head on perfectly elastic, e value is equal to what? 1. so when we will try to go back to our actual question, and we have to get the values of v1 and v2. so ipo parunga right side la irukra minus v1, let us take it to the left side. minus v1 enna agum? plus agum. so u1 minus u2 plus v1 is equal to what? v2. so the v2 oda value அப்படியே இந்த v2 எடுத்துட்டு substitute in the equation 1. the equation 1 ல substitute பண்ணுங்க. substitute பண்ணா என்ன வரும்? m1 into u1 LHS பாருங்க minus m1 into v1 is equal to m2 into v2 பதிலா நம்ம என்ன substitute பண்ண போறோம்? u1 minus u2 plus v1. ஓகேவா? இதனை this is in place of v2 minus u2. okay, so this is coming in place of v2. அந்த v2 பதிலா நம்ம என்ன substitute பண்ண போறோம்? u1 minus u2 plus v1. ஓகேவா? so இப்ப பாருங்க what is it? m1 u1 minus m1 v1 is equal to m2 into உள்ள என்ன இருக்கா? u1 minus 2u2 plus v1. என்னது? m2 u1 minus 2m2 u2 plus m2 v1. அவ்வளவுதான் வந்தது. So we are able to get the answer. இதுக்கப்புறம் நான் ஜஸ்ட் ரீஅரேஞ்ச்மெண்ட் இங்க பாருங்க, இந்த ஈக்குவேஷன்ல v1 தவிர everything is else is already given, right? So in this equation, right, other than v1 everything is given. So LHS la what are we having? m1 u1 minus m1 v1. RHS la m2 u1 minus 2 m2 into u2 plus m2 into v1. இங்க என்ன தெரியுமா, just bring this அந்த v1 term மட்டும் let us bring it to the right side. Here take these two to the left side. பாருங்க, left side ல m1 u1 minus m2 u1, இது minus side, plus 2 m2 into u2 is equal to RHS ல m1 v1 plus m2 v1. இது என்னது, m1 plus m2 into v1. ஆக்சுவலி என்ன தெரியுமா, நம்ம இந்த டெரிவேஷன் எல்லாம் பண்ண தேவையில்லை, பிகாஸ் எனிவே ஃபார் த நீட் எக்ஸாமினேஷன் நமக்கு என்ன தேவைப்படும், வில் ரெக்வயர் ஒன்லி த ஃபைனல் ரிசல்ட். இந்த ஃபைனல் ரிசல்ட் மட்டும் நமக்கு தெரிஞ்சா போதும். பட் why are we doing it is we need to understand எப்படி வருதுன்னு சொல்லிட்டு. It's not like somebody is giving the formula. Final velocities are basically coming from the two equations. What are the two equations? ஒன்னு conservation of momentum, ரெண்டாவது conservation of kinetic energy. அந்த ரெண்டு equations வச்சு தான் we are able to derive the values of v1 and v2. பாருங்க, so எங்க தெரியுமா, take u1 common, so m1 minus m2 into u1 plus 2m2 into u2. right side ல இருந்து bring the m1 plus m2 to the left side. அது எங்க போய்டும், denominatorல போய்டும். so split பண்ணி பாருங்க, m1 minus m2 divide by m1 plus m2 into u1. so v1 ஓட வேல்யூ என்ன, m1 minus m2 by m1 plus m2 into u1 plus second term இருக்கு, second term என்னது, 2m2 by m1 plus m2 into u2. so இதுதான் final expression for the v1. so இந்த expression நம்ம கண்டிப்பா we should remember it. ஏன் தெரியுமா, நான் சொன்ன மாதிரி we have got straight questions to find the velocities of the particles after the collision by using this particular formula. so இதுல இருந்து what are we having, v1 வருது நம்ம கிட்ட. so what are we having, v1 we are able to get. what is the v1, m1 minus m2 divided by m1 plus m2 into u1. so u1 is what, the particle 1 ஓட initial velocity. அதுக்கப்புறம் second term என்ன பாருங்க, 2m2 by m1 plus m2 into u2. so இப்போ symmetrically, right, so இப்போ இந்த v1 ஓட வேல்யூ எடுத்துட்டு you go and substitute any of the equations. நீங்க ஏதாவது equation substitute பண்ணா you will get the v2. so let's say take this and then equation 1 ல நீங்க substitute பண்ணுங்க, you will get what, v2 ஓட வேல்யூ வரும். பட் என்ன தெரியுமா, because these expressions are symmetric, right, ஏன்னா m1 is identical to m2 தானா, symmetric. so இந்த v1 ஓட value expression பார்த்துட்டு we can write what will be the similar expression for the v2. so v2 ஓட expression எப்படி வரும் பாருங்க, வேணும்னு நீங்க செக் பண்ணி பார்க்கலாம். but what we'll do now is we'll just try to write the v2 formula by looking at this one. பாருங்க, for the particle 1 ஓட final velocity rate m1 minus m2, so means what, the mass of first particle minus mass of second particle divided by m1 plus m2 into u1. okay, so corresponding இங்க என்ன வரும் பாருங்க, m2 minus m1 by m1 plus m2, என்ன particle 2 ஓட இதுல நம்ம சப்ட்ராக்ட் பண்ணணும், into u2. okay, plus second term என்னது, 2 times the mass of the second particle by m1 plus m2 into u2. so எங்க வரும், 2 times the mass of the other particle which is m1. so identical. so v1 நமக்கு வேணும்னா what you will get, அந்த u1 ஓட மல்டிப்ளிகேஷன் ஃபேக்டர் என்ன வரும், m1 minus m2 by m1 plus m2. அதுதான் u1 ஓட மல்டிப்ளிகேஷன் ஃபேக்டர். u2 ஓட மல்டிப்ளிகேஷன் ஃபேக்டர் 2m2, 2 times the mass of the other particle by m1 plus m2. ரெண்டுதிலும் denominator காமன் தான், m1 plus m2. இப்போ நமக்கு v2 வேணும்னு பாருங்க, we will get what, m2 minus m1 by m1 plus m2 into u2 plus 2 times the mass of the other particle m1 by m1 plus m2 into u1. symmetrically வரும். okay, so பாருங்க, these are the final expressions. So v2 oda value enna idu nama correct ah gnabagam vechukanum. Okay, because if you remember these formula means we will be able to solve straight questions on this. அப்படியே வரும், like I'll show you the kind of questions we can get based on these formula. பாருங்க v2 oda value enna m2 minus m1. so the multiplication இங்க என்ன தெரியுமா இப்படி நம்ம பார்க்கணும். so v2 oda இதுல we will get multiplication factor for u2 வரும், அந்த மாதிரி multiplication factor for u1. so u2 oda multiplication factor enna m2 minus m1 by m1 plus m2. u1 oda multiplication factor enna, this is actually the other particle. so enna நம்ம இங்க பார்க்கிறது என்ன, second particle oda v2. so the other particle initial velocity oda multiplication factor என்ன வரும் பாருங்க 2m1 by m1 plus m2. so நீங்க யோசிச்சு பாருங்க எப்படி, how you will feel it easy to remember. but என்னன்னா கண்டிப்பா we should remember this expression, அதுதான் நமக்கு வேணும். ஓகே, அதுக்கு அப்புறம் இங்க பாருங்க v1 நமக்கு வேணும் வெச்சுக்கோங்க, particle 1 ஓட final velocity. அங்க என்னது பாருங்க, we'll have a multiplication factor for u1, அந்த மாதிரி we'll have a multiplication factor for u2. so multiplication factor for u1 is what, m1 minus m2 by m1 plus m2. what is the multiplication factor for u2, 2m2 by m1 plus m2. நீங்க கொஞ்சம் அந்த straight அந்த formula base பண்ணி questions நீங்க கொஞ்சம் practice பண்ணாலே you will be able to get the comfort of remembering these expressions. ஓகேவா, பட் என்னன்னா we should finally be able to remember these two expressions. இந்த expressions தான் நமக்கு requirement, major requirement in a perfectly elastic head on collision. okay, so பாருங்க இதுல என்ன தெரியுமா, what kind of questions can come. there are two kind of questions that can come on this. first thing என்னன்னா, they will straight away ask us what is the v1 and v2 values. அப்படியே like நான் சொன்ன மாதிரி this model of question has also come repeatedly. ரெண்டாவது என்ன தெரியுமா, if you are having the particles, the total kinetic energy is conserved. and initial kinetic energy of the particles is equal to final kinetic energy, அது conserved தான். but the individual particle, so ஒரு particle oda kinetic energy நீங்க எடுத்து பார்த்தா it might not be conserved. okay, so they can ask what is the change in kinetic energy for a specific particle. ஏன்னா totally kinetic energy conserved தான், but நீங்க ஒரு particle எடுத்து வெச்சுக்கோங்க, the particular particle oda kinetic energy may not be conserved, so you can have questions on that. அந்த மாதிரி questions வரலாம். பாருங்க, look at this one, two balls masses m and 2m moving in opposite directions collide head on. so idhula theriyuma opposite directions nu sonna what is it, எப்படி like 2m oda velocity is what, 2v, m oda velocity is v. okay, so they are moving in opposite directions, collide elastically with velocities v and 2v, இப்படி தான் வரும். okay, so when we are having opposite directions அப்ப நம்ம என்ன பண்ணனும், already we have the equations, right? இங்க என்னது, they are asking find their velocities after the collision. v1 and v2 values கேக்குறாங்க, அவ்வளவுதான். they are asking us what, v1 and v2. so v1 formula என்ன, what is the formula for v1? v1 is what, m1 minus m2 by m1 plus m2 into u1 plus 2m2 by m1 plus m2 into u2. அதுதான் v1 ஓட வேல்யூ. so இந்த ஃபார்முலா நம்ம சப்ஸ்டிட்யூட் பண்ணும்போது we have to take the sign convention part. so இங்க பாருங்க, they are moving in opposite direction means one direction we have to take it as positive. generally என்னன்னா we can take the right side to be positive, அப்ப left side will be negative. okay, so look at this, we will take this as m1. m1 is what, 2m mass, இது என்னது m2. so u1 அந்த பக்கம் இருக்கா, positive direction, so u1 will be what, 2v. but u2 பாருங்க, u2 is to the left side, so we have to take it as what, minus v ஆயிருக்கும். so in that formula நம்ம அந்த velocity substitute பண்ணும்போது we should follow the sign convention. we should be following the sign convention. sign convention சொன்னா what is it, the sign convention we follow in the kinematics. என்னது, if you take one direction நீங்க positive எடுத்தா அதுக்கு opposite direction we have to take it as what, negative. அவ்வளவுதான். so இப்ப பாருங்க, we just have to go and substitute. so v1 என்னது, m1 minus m2 means m1 is what, 2m. so 2m minus m by 2m plus m equal to 3m into u1 which is 2v plus 2m2 into u2 எவ்வளோ minus v. அவ்வளோதான். So that's the kind of questions we'll have. பாருங்க numerator என்ன 2m minus m means m. ஓகேவா? ஸோ அப்படியே அந்த m கேன்சல் ஆகிடும். ஸோ 2v by 3. அதுக்கப்புறம் இங்கே என்ன, வாட் இஸ் திஸ், இங்கே அதுதானா 2 கேன்சல் ஆகிடும், மைனஸ் வரும், minus 2v by 3. வாட் இஸ் திஸ், 0. வாட் இஸ் திஸ், 0. ஸோ வாட் இஸ் த v1 ஓட வேல்யூ என்னது, it is coming as what, 0. v1 value is what, 0. ஓகேவா? அப்புறம் we will have to look at what is the other thing. We have to look at what is the v2 value. பாருங்க, what will be the v2 expression? All these questions are what, just substitution. The formula அப்படியே நம்ம substitute பண்ணா we will be able to get the answers. So v2 formula என்ன, that's why நீங்க solve பண்ண ஒரு சில questions solve பண்ண வச்சுக்கோங்க, we will be able to clearly remember this formula. So v2 என்ன வரும், you will have a factor for u2, அந்த மாதிரி you have a factor for u1. What will be the factor for u2, m2 minus m1 by m1 plus m2. What is the factor for u1, 2m1 by m1 plus m2. Okay, so பாருங்க m2 minus m1 means what, m minus 2m வரும், divide by 3m into u2. What is u2, minus v, plus 2m1 means what, 2 times 2m divide by 3m into u1. u1 ஓட வேல்யூ என்ன, 2v. அப்படி நம்ம சப்ஸ்டிட்யூட் பண்ண வேண்டியது, அவ்வளவுதான். ஓகே, இங்க பாருங்க m minus 2m எவ்வளவு, minus m. so minus minus plus ஆயிடும். ஓகே, so what is it, v by 3. இது என்னது, v by 3. ஓகேவா? so next இங்க என்ன வரும் பாருங்க, 2 into 2 எவ்வளவு, 4. 4 2s are 8. so plus 8 by 3v. so total now what is it, v by 3 plus 8v by 3. what is it, 9v by 3, which is the 3v. 9v by 3 which is what, 3v. means collision க்கு அப்புறம் என்ன ஆகும் பாருங்க, m1 is what, 2m தானா. so இங்க நம்ம எழுதலாம், so v2 is equal to what, 3v. v2 is equal to what, 3v. okay, இப்போ பாருங்க collision க்கு அப்புறம் 2m is coming to rest because of the final velocity என்ன, after the collision what is the velocity, 0. and this m, this is our m2, right, he is having a velocity of how much, 3v. 3v I'm saying it is in the forward direction at the right side. okay, it is in which direction, right side. இங்க என்ன தெரியுமா, you can even check how the coefficient of restitution. coefficient of restitution is what is it, v2 minus v1 by u1 minus u2. நீங்க செக் பண்ணி பாருங்க, coefficient of restitution, right, will be coming as what, 1. so what is the e value, v2 minus v1 by u1 minus u2. அதுதானா, v2 எவ்வளவு, 3v, v1 எவ்வளவு, 0. u1, what is u1, 2v minus u2 எவ்வளவு, minus v. so பாருங்க நியூமரேட்டர் 3v வரும், டினாமினேட்டர்ல minus minus plus ஆயிடும், இதையும் 3v தான். because for a head on perfect elastic collision, what is the coefficient of restitution at a value, e will be equal to 1. okay va? so இப்படிதான், we just have to remember those two velocity formulas. the formulas நீங்க remember பண்ணா you will be able to solve the questions. so இது ஒரு type of question, they will ask us straight away what are the velocities of the particles after the collision. collision க்கு அப்புறம் what are the velocities. பாருங்க, this is a question multiple years ல வந்தது, 2016, 1994, 1991. two identical balls and சொன்னா what is it, their masses are same. so இதுல என்ன தெரியுமா, m1 is equal to m2 is equal to m. identical balls and சொன்னா their masses are what, same, having the velocities 0.5 and minus 0.3 respectively collide elastically in one dimension. means it is what, elastic head-on collision. the velocities of b and a after the collision will be respectively. collision க்கு அப்புறம் what will be the velocities of B and A? இங்க என்ன தெரியுமா, they are playing a little bit of trick. பாருங்க, they are giving a velocity. Say for example, A நம்ம particle 1 ன்னு சொன்னா B will call it as particle 2. A ஓட initial velocity என்ன பாருங்க, 0.5. B initial velocity எவ்வளவு, -0.3. நம்ம sign convention ஓட values எடுக்கணும். ஓகேவா? they are asking us what, order change பண்ணிட்டாங்க பாருங்க, the velocity of B and velocity of A. So finally நம்ம answer conclude பண்ணும்போது we have to give what is the V2 value first, அதுக்கப்புறம் we have to mention V1. So that is also a thing, because finally நமக்கு V1 ஓட வேல்யூ வரும், V2 ஓட வேல்யூ வரும். வந்ததுக்கு அப்புறம் we have to choose which order, எந்த ஆர்டர் நம்ம சூஸ் பண்ணணும். they are asking the velocity of B and A after collision, means first நம்ம V2 வேல்யூ மென்ஷன் பண்ணணும், அதுக்கப்புறம் we have to mention the value of V1. ஓகேவா? so பாருங்க, what is this, in fact இது என்ன தெரியுமா, we will discuss about இது ஒரு special case of the head on collision in perfectly elastic category between two identical balls or between two identical objects. இங்க பாருங்க, the objects are not identical, means m1 will be equal to what, m2. if the objects are identical, m1 will be equal to what, m2. okay, so in the result நம்ம conclude பண்ண போறோம், because we will see this special category. but இங்க என்னன்னா, we will try to solve the question just like the way we do normal problems. எப்படி, we will look at the V1 formula and V2 formula. what is the V1 formula, m1 minus m2 by m1 plus m2 into u1 plus 2m2 by m1 plus m2 into u2. இங்க பாருங்க, m1 is equal to m2, அதோட வேல்யூ நம்ம m1 வச்சுக்கலாம். if m1 is m2, right, பாருங்க u1 ஓட மல்டிப்ளிகேஷன் ஃபேக்டர்ல என்ன இருக்கா, m1 minus m2 வருது. if m1 is m2 means this is 0 தானா. அப்ப v1 பாருங்க, what is it, 2m by denominatorல m plus m எவ்வளவு, 2m into u2. so v1 will be equal to what, u2. so if you are having the perfectly elastic collision in head on type between two identical objects, அப்ப என்ன வரும் பாருங்க result. what is the result we are going to get, check it. v1 ஓட வேல்யூ என்ன, u2, means particle 1 ஓட final velocity is what, particle 2 initial velocity. okay, so இது வச்சு நம்ம conclude பண்ணலாம், because both will be identical தானா. so then we can just look at the other expression also. other expression என்ன, v2 ஓட value. what is the v2 expression, m2 minus m1 by m1 plus m2 into u2 plus 2m1 by m1 plus m2 into u1. இதுதானா. so இங்க அப்படிதான், m2 minus m1 எவ்வளவு, 0. so பாருங்க, 2m by 2m into u1, அதுதான் v2 ஓட வேல்யூ. so v2 வேல்யூ என்ன, u1. so என்ன ஆயிட்டிருக்கா, collisionக்கு அப்புறம் the particles are just interchanging their velocities. observe பண்ணி பாருங்க. so what is v1, u2. particle 1 ஓட final velocity is what, particle 2's initial velocity. okay, and particle 2 final velocity is what, particle 1 ஓட initial velocity. they are interchanging the velocities. என்ன ஆயிட்டிருக்கு, they are basically interchanging the velocities. அப்ப என்ன, so what is it, v2 is what, u1 means 0.5. v1 is what, u2 means minus 0.3. but என்ன தெரியுமா, பாருங்க questionல they're asking the velocity of B and A, means we have to mention first என்ன mention பண்ணணும், v2 mention பண்ணணும், அதுக்கப்புறம் v1. so v2 is what, v2 எவ்வளவு, 0.5, v1 minus 0.3. பாருங்க, so what is the correct answer, v2 is 0.5, v1 minus 0.3. okay வா. so we have to look at what is the order in which they are asking. so என்ன தெரியுமா, we have covered one special category in the head on or 1D elastic collision. என்னது, the collision where the two objects are having the same mass, identical objects. okay, so அதுல என்ன ஆகும், the particles the collision க்கு அப்புறம் they will simply interchange their velocities. okay வா. so அடுத்த question பாருங்க, this is another question. okay, this is another question which has come in the 1998. இதையும் அப்படிதான் as it is. Two equal masses ன்னு சொன்னா m1 ஓட value will be equal to m2, which we can say is some m. Moving on a same straight line means 1D. 1D and சொல்றதுக்கு பதிலா they are saying what, moving along the same straight line means that is the 1D motion or the head-on type of collision is going to happen with velocities 3 and -5 respectively. Okay va? Their velocities after the collision will be, so எங்கன்னு தெரியுமா? So பாருங்க m1 ஓட velocity என்னது 3, m2 ஓட velocity எவ்வளவு -5. They are asking what is, this is our u1, this is our u2. They are asking what are the velocities after the collision respectively, means எங்கன்னு தெரியுமா? They are asking straight away this only, v1 v2. இதுக்கு முன்னாடி நம்ம பார்த்த ப்ராப்ளம் என்ன, they have changed the order. So இங்க ஆர்டர் சேஞ்ச் பண்றது கிடையாது. They are asking what are the velocities of the particles after the collision respectively. இங்கேயும் அப்படிதானா, சேம் as it is நம்ம பார்த்த மாதிரி என்ன வரும், after the collision since they are particles of equal masses, right, என்ன ஆகும், they will interchange the velocities. திருப்பி நம்ம அந்த ஸ்டெப்ஸ் நம்ம பண்ண தேவையில்லை, ஏன்னா because just only we did it right. So straight away we can write the answer. என்னது, v2 will be equal to what, u1, and v1 will be equal to what, u2. They will interchange the velocities. பாருங்க v1 எவ்வளவு, u2 means -5, v2 எவ்வளவு, u1, but we have to mention what in the same order, means we have to mention first we have to mention v1 எவ்வளவு, -5. So -5 meter per second, comma v2 எவ்வளவு, 3. செக் பண்ணி பாருங்க, what is it? These are the velocities of the particles after the collision. So we are having 1D perfectly elastic collision between two identical masses. And now after the collision, they both will simply interchange their velocities. Okay va? So அடுத்து பாருங்க, this is another concept. They will ask us the change in the kinetic energy for a single particle. இந்த மாதிரி questions வரலாம். Look at this. A moving body of mass m makes a head-on elastic collision with another body mass 2m, which is initially at rest. So another m is moving. Okay. It is having a head-on collision perfectly elastic with a 2m which is at rest. So we will take it as what, u1 as some v. avanga velocity kudukala. Okay, so we will take it as some v. u2 evala 0 because he is at rest. Find the fraction of kinetic energy lost by the colliding particle. So this colliding particle generally this is the common language. Okay, so the particle that is coming to collide, right, so one of them is at rest nechkonga. Oh, before the collision both are not moving, one of them is at rest, only one of them is moving and coming and colliding. So that particle which is moving, right, adukku enna theriyuma, we will also call it as what, colliding particle nu solluvaanga. We will also call it by the name colliding particle. Okay, so paranga this is coming and colliding, right. So what they are asking, the fraction of kinetic energy lost by the colliding particle. When we have taken u1 to be equal to v, the final answer la varakudadu. This v should not be coming in the final answer, because we are going to only look at what the fraction of kinetic energy lost by the colliding particle after the collision. Paranga, we require only the v1, right. Enna namakku enna thevapadum, we require only the v1, right. So v1 evala, what is the v1 formula, m1 minus m2 by m1 plus m2 into u1 plus 2m2 by m1 plus m2 into u2. The formula அப்படியே we should remember it. Okay, so once you practice some problems, right, you will get the command. Now paranga, u2 0. So அப்படியே the second term full ஆவே 0 ஆயிடும். m1, so v1 value பாருங்க, m1 minus m2. So m1 is what? m2 எவ்வளவு? 2m divide by m1 plus m2, which is totally 3m, into u1. u1 is we are taking it as b. பாருங்க, what is it? m minus 2m means what? Minus m. Minus m by 3m into v. So minus v by 3 வருது, which means what? Sign convention. So collision க்கு அப்புறம் the m1 particle, which is the particle of mass m, அது எப்படி மூவ் ஆகும்? It will move exactly நம்ம ரைட் சைடு, இது நம்ம பாசிட்டிவ் எடுத்தா it will be moving in the opposite direction. It will be moving in the opposite direction with how much speed? v by 3 speed. அதுதான் அதோட significance. Minus and சொன்னா what is it? Sign convention wise it will be moving in the opposite direction with that particular velocity ஓட value. ஓகேவா? So இங்க நமக்கு என்ன வேணும்? We are looking for what? The fraction of kinetic energy lost by the colliding particle. So colliding particle ஓட initial kinetic energy எவ்வளவு பார்க்கலாம் first. We are only looking at the colliding particle. Ke1 எவ்வளவு? half into m into v square. Ke2 final, half into m into what is the speed? v by 3. Okay va? So what is it? Half into m into v square by 9, that is the Ke2. So they are asking fraction of kinetic energy lost by the colliding particle. So on the expression path, what is the thing we will understand? Ke2 oda value is lesser than Ke1 dana. Ke2 oda value is lesser than Ke1, which means what? The loss in kinetic energy and so what is it? Ke1 minus Ke2. Fractional loss and so what is it? Loss in kinetic energy by original kinetic energy. Fractional loss means what? Loss in kinetic energy by original kinetic energy, which is what? Half m into v square minus half m v square into 1 by 9 divided by half m v square. So பாருங்க, both numerator denominator என்ன பண்ணலாம்? We can cancel off. இது நம்ம கேன்சல் பண்ணலாம். half m v square காமன் எடுத்து நம்ம கேன்சல் பண்ணலாம். கேன்சல் பண்ணா see half m v square காமன் எடுங்க. நியூமரேட்டர்ல we have 1 minus 1 by 9 இருக்கும். டினாமினேட்டர்ல what is 1 minus 1 by 9 means 8 by 9. That's it. என்ன கேக்குறாங்க? What is the fraction of kinetic energy lost by the colliding particle கேக்குறாங்க. So that will be what? For the colliding particle kinetic energy loss ஆகும். So we are getting what? The initial kinetic energy minus final kinetic energy. அதுதான் loss of kinetic energy சொன்னா. So loss of kinetic energy by original kinetic energy. Okay. So இப்படி ஒரு question வரலாம். Like generally என்ன? For the perfectly elastic head on la, they will either ask us the final velocities, which we will do by using that formula, on the v1 v2 formula. அதுக்கப்புறம் this kind of questions also can be asked. What is it? Change in kinetic energy for a specific particle. ஒரு particle ஓட kinetic energy change, what will be the value ன்னு சொல்லிட்டு அப்படி questions வரலாம். Okay. So பாருங்க, this is a question that has come in the NEET 2019. Okay. A body A of mass 4m moving with a speed u collides with another body B of mass 2m which is at rest. Okay va? The collision is what? Head on and elastic in nature. After the collision, the fraction of energy lost by the colliding body A. So இதுக்கு முன்னாடி நம்ம சால்வ் பண்ண क्वेश्चन க்கு difference என்ன? In the previous question, the heavier mass, பாருங்க, the previous question என்ன? The heavier mass is at rest. Moving body is m and 2m is at rest. இங்க opposite. இங்க என்னது? 4m is moving. பாருங்க, 4m is moving with the velocity u initially. 2m எப்படி இருக்கா? 2m is at rest. Okay, this is A and this is B. After the collision, the fraction of energy lost by the colliding body A. இங்கே எப்படிதா? We have to calculate what is the fraction of energy lost by the colliding body A. So பாருங்க, what is it? Kinetic energy of the body A. நம்ம என்ன பார்க்க போறோம்? வெறும் அந்த body A மட்டும். Initial kinetic energy எவ்வளவு வரும் பாருங்க? half into அந்த object A ஓட mass, which is 4m into u square. okay va. So this is the this is the initial kinetic energy. So half நீங்க cancel பண்ணா what is it, 2m into u square வரும். Okay, அடுத்து now we will require the final kinetic energy. அதுக்கு we will first of all need what is the final velocity of that 4m. So 4m நம்ம என்ன particle 1 ன்னு சொல்லலாம், 2m will be particle 2. v1 formula என்ன, m1 minus m2 by m1 plus m2 into u1 plus 2m2 by m1 plus m2 into u2. இங்க பாருங்க u2 எவ்வளவு, 0 தானா. u1 is equal to u, particle 1 ஓட initial velocity என்ன u, particle 2 ஓட initial velocity 0, u2 0 means அப்படியே அந்த second term 0 ஆயிடும். m1 minus m2 4m minus 2m by 4m plus 2m எவ்வளவு 6m into u1. பாருங்க numerator 2m இருக்கும், what is it, v1 எவ்வளவு 1 by 3 times of u, v1 எவ்வளவு 1 by 3 times u. பாருங்க what is ke2, same for that particle a, ke2 எவ்வளவு half into அதோட mass into velocity is what, after collision what is the velocity, 1 by 3, so u by 3 the whole square. அப்படிதானா. So what is it, so 2, so 2m u square by 9. So u by 3 நம்ம ஸ்கொயர் பண்ணா என்ன வரும், u square by 9 வரும், அவ்வளவுதான். Okay, so this is the initial kinetic energy of the particle A before the collision and kinetic energy after the collision. They're asking what is the loss of the kinetic energy by the particle A. Adana colliding particle means particle A. So loss of kinetic energy fraction, same, ke1 minus ke2 by ke1. Adana fraction, ke1 is what, 2m u square, ke2 is what, 2m u square by 9 divided by ke1 எவ்வளவு, அப்படியே நீங்க நியூமரேட்டர்ல 2m u square காமன் எடுத்தா திருப்பி என்னது 1 minus 1 by 9. This is what, fraction of energy lost by A. என்னது, the fraction of the kinetic energy lost by the colliding body A. Okay வா. So பாருங்க this is what we have seen in the questions also, right? So in the perfectly elastic head on type la we will look at some special cases. Then iniki we will try to cover the case that we already got in the questions. So this is the velocity v1 and v2 values, right? If the particles undergoing the collision, right, are having the same masses. Okay, so then already we have talked about one particular terminology, and if one of the object is at rest, other is coming with a velocity, so we'll call this as what, we'll call it as a colliding particle. Sometimes in some textbooks, right, you will see this nomenclature also. And paranga projectile and target and solvanga. See, say for example, m2 is going towards the right, m1 is also going towards the right side. Okay, so the collision will happen when u1 is more than u2. Appadidana. So m1 is going to approach, means u1 value will be more than u2. So அந்த மாதிரி cases you will call this as what, you will call it as what, a projectile and சொல்லுவாங்க, and this will be called as what, target. Target is like what, something to which you are hitting it. Okay, so the colliding particle can be also called as what, projectile and சொல்லலாம். The colliding particle can be also called as what, projectile, and it is like where you are hitting, that will be generally called as what, target. This is one common nomenclature that is sometimes used. Okay va. So paranga, if both the particles which are in this head on 1D collision are having the same mass, means m1 is equal to m2, m1 is equal to m2. அப்படி இருந்தா what is going to happen paranga, straight away in the v2 expression la m2 minus m1 and the particular term என்னடும் 0. அது மாதிரி நீங்க பாருங்க, this will be 0. So v2 எவ்வளவு, 2m by 2m into u1, which means v2 is equal to u1. இதான் நம்ம ஆல்ரெடி இது முன்னாடி பார்த்திருக்கோம். சோ இங்க பாருங்க v1 எவ்வளவு 2m by 2m. so இந்த equal mass we are calling as m, ஓகேவா, into u2. இது cancel ஆயிடும். so v1 is equal to what, u2. so collision க்கு அப்புறம் what is going to happen, both these particles will interchange their velocities. என்ன ஆகும், both the particles will interchange the velocities. இதுக்கு என்ன தெரியுமா, ஒரு common example, the balls on the billiards table. so billiard balls னு சொல்லுவது தெரியுமா, like look at this. இங்க பாருங்க, in a billiard ball game, so you will have the the balls on the table, where you will target one of the balls by hitting it with the other one. okay, so இங்க பாருங்க, using this stick, right? okay, you are first pushing the white ball, and that is going to come and hit the blue one. okay, so both this white and blue both have the same mass, identical. they both are identical. okay, now பாருங்க, this white we will take it as what, object 1, which is coming with the velocities. blue is what, that is at rest. பாருங்க initially எப்படி இருக்கா, blue is at rest, right? collision complete ஆன உடனே what are you seeing, almost. சரி, நம்ம practical இது பண்ணும்போது you will have some deviations, but almost என்ன ஆயிட்டு இருக்கு பாருங்க. just observe this, it's a slow motion. slow motion when you observe it, right? what is that you're seeing, almost the white v1 எவ்வளவு is becoming u2, which is 0. பாருங்க, white is almost coming to rest தானா, but since we are doing a practical இதுல we'll have some deviations, but almost the white is coming to rest. and v2 எவ்வளவு பாருங்க, u1. so you'll see that blue ball is almost moving forward with the same velocity. the white ball oda initial velocity எவ்வளவு தெரியுமா, the blue ball is moving forward with the same velocity almost. so this is a perfect example to understand this particular case of head-on elastic collision between two identical objects. so again I try paranga, the white ball is coming with the velocity and colliding the blue one, which is at rest. collision ku appuram enna agum, as per our understanding they will interchange the velocities, means white is coming to rest, blue is going forward with the same velocity, whatever is the initial velocity of the white ball. okay va, so this is a special case in terms of the perfectly elastic head-on type of collision. okay, next session we will start with, there are some more special categories in this, in the perfectly elastic head-on type we have some more special types. okay, and the special categories discuss பண்ணிட்டு we will go into the inelastic and perfectly inelastic in this 1D type of collision. okay, so we'll look at the special cases in this perfectly elastic type 1D la. adukapram we'll go into the inelastic collision and then perfectly inelastic in case of the 1D type of collision or the head-on collision. okay, so we'll see in the next class.